Hello, this is Michael.
And this is Ryan, and this is our Lab 9 on diffraction. So for part A, we're looking at different diffraction patterns through the different apertures. And we started with the single slit aperture. And as we move our camera away, we move from the image of the slit to the diffraction pattern. And we can observe that pattern as a sinc function. And moving on to the double slit, we get that same sinc function as an envelope, but it's modulated by a higher frequency carrier function, and this is due to the interference from the light from the different slits. For the circular aperture, we should see an area disk diffraction pattern, and in order to check that, we plotted our data against two functions using MATLAB. And one of these functions is the SOM function, and the other one was the sinc function. And what we found is our data was much better matched by the SOM function since the pattern is radially symmetric. Moving on to the square aperture, we get the same kind of pattern that we see in the single slit, except it is on two axes. So we can see on the x and y axis, we get that pattern. For the triangle aperture, we see a diffraction pattern with three kind of prominent spikes and not just the image of the triangle. And for all these apertures, we observed a distance where the diffraction pattern became apparent, and this is analogous to the transition to the Fraunhofer region where the diffraction comes.
So for part B, we used a beam profiler to profile a Haney laser beam. We measured both the x and y axis of the beam widths at different distances from the source. We found that there was not much of a difference between the x and y beam widths, and this indicates a low ellipticity of the beam. We used a quadratic fit to model diffraction, finding the smallest beam size to be around 247 microns. We then used trigonometric identities to find the diffraction angle and numerical aperture. We found a diffraction angle of 0.069 degrees and a numerical aperture of 0.0006. This is a low value because the laser is trying to limit the diffraction of the light beam. Thanks for watching, and this is our lab video on Lab 9 diffraction.